Welcome to the Dynon channel, your video source for information, education, and training on Dynon Avionics' industry-leading line of integrated avionics for experimental amateur-built and light sport aircraft. Today's topic, SkyView system, expert autopilot mode, altitude capture, and vertical transitions.
Hello. In this video, I'm going to finally tackle a topic that customers have been clamoring for, and that is controlling the SkyView Autopilot in the vertical axis using the expert menu system or control scheme. Quite some time ago, I started an autopilot series and I covered lateral navigation using the autopilot in the roll axis. I'm just now finally getting back to covering vertical axis control. Another housekeeping item, the screen you see in front of you now is one of our new SkyView HDX displays, and it's currently set up to be working with a flight simulator program so that I can give a realistic presentation without being in the cockpit. We live and work in the Pacific Northwest. It's late November and it's not very good flying weather today. I've used that excuse before, but I've finally committed to doing these videos in the office with a flight simulator so that I won't be constrained by weather. So bear with me, you may see a few quirks related to the flight simulator, but it'll be sufficient for our purposes. And then finally, the HDX system differs from the original SkyView Classic and SkyView Touch in that it has a different menu system and some additional controls that aren't available on the original SkyViews. For those of you that are familiar with SkyView, you'll know that your autopilot control is accessed on button 4 of your main menu bar. In the SkyView HDX you see here, there is no autopilot menu button on the main menu. And instead, I'm going to be using an autopilot control page that is unique to the SkyView HDX. I access that in two ways, either the menu button here and then press autopilot, or alternatively, I can simply touch the autopilot enunciation area at the top. Those of you with a SkyView Touch system are familiar with the touch access to the autopilot menus. So as I go forward, I'm going to use this autopilot control panel you see here for accessing all of the autopilot functions. If you have a original SkyView Classic or SkyView Touch, you have access to all of these same controls, but they're distributed across an autopilot menu and then two separate submenus for pitch and roll control. And most of my topic today is going to be covering the basic autopilot and flight director on-off buttons. Those are on your main autopilot menu in SkyView Classic and Touch. And then we'll be talking about controls in the pitch axis, which are available on the pitch submenu in SkyView. And then lastly, I'll point out that some of you may have installed our optional autopilot control panel, and I have an example here in the upper left-hand corner of the video. That's an optional button panel. It's not required, but it's usable with both the original SkyView Classic and Touch and the HDX system. This happens to be a vertical orientation of the autopilot control panel. We also offer one in the horizontal orientation. The HDX control page for the autopilot is oriented almost identically to the horizontal version of the autopilot control panel. So that's the setup. I'm going to close the autopilot control panel for the moment. And we're going to proceed to take off from this runway. We're here at my home airport in Everett, Washington, called Payne Field or Snohomish County Airport. We're going to take off on this runway, and I'm going to, once I lift off and reach adequate speed for the autopilot, I'm going to show you how to engage the autopilot in the simplest mode, and then proceed from there to execute an altitude capture and hold, and then altitude transitions up and down. Okay, now I'm going to unpause my simulator, and bear with me while I attempt to take off. Sometimes my liftoff in Flight Simulator is a little sketchy. So we're rolling down the runway here. Airspeed is climbing quickly. I'm flying a Cessna, so I'm waiting to get a good nose wheel shimmy before I rotate. 85 knots should do it. And here we are rotating. I'm hoping to stabilize at about a 400 foot per minute climb, thereabouts. And I need to activate the autopilot control page. So I can either touch the status bar annunciation for the autopilot or select menu, autopilot. Having done that, I'm now ready to touch the AP button to engage the autopilot. And when I do, notice that the autopilot stabilizes and rather engages in the vertical speed mode and in the roll hold mode. So what do those mean? In the roll axis, roll hold means hold whatever bank angle I was achieving when I turned the autopilot on, and it's holding roughly a bank angle 0 attitude. And on the pitch axis, notice it engaged in the vertical speed mode as indicated by the VS button, engaged green. And on the top status bar, it says it's achieving a vertical speed target of 400 feet per minute. That was the rate I was achieving when I did engage the autopilot. And the white indication says it's armed to engage an altitude when I get there. Now in my case, I had previously set an altitude bug target of 2,000 feet. If you haven't set an altitude target, maybe it'll be blank dashed lines like we see here on the indicated airspeed bug, or you might have it still set at 0 altitude. The autopilot is engaged in the vertical speed mode and it's armed to capture a target altitude, but it will only capture if that altitude bug is at a rational level in the direction you are heading. In this case, if we're climbing, the altitude bug has to be set at a value above our current altitude. If it's not set at all, meaning we have dashed lines, or if it's set at an altitude that's below our current altitude when we engage the autopilot, it will continue to climb unchecked until aircraft performance peters out. So again, in my case, we're climbing through 13,000 feet, and the autopilot is going to attempt to level off at my bug altitude. I'm going to lower that target altitude to 17,000 feet, and we'll watch it level off. While it's getting ready to level off, I'm going to just point out that green on the control panel denotes a mode that is engaged, meaning the autopilot is controlling the autopilot servos in that mode. White, as we see on the Alt Hold button, means that mode is armed and it's prepared to sequence that to that mode when the time is appropriate, when a certain condition comes about. In our case, it will sequence to the altitude hold mode when we get very close to 17,000 feet. And we're just about to see that happen. We're rolling through 6,000 feet. The autopilot already sequenced to the altitude hold mode. It's going to continue climbing until it actually levels at 1,700 feet. And you can see it's already moderating my climb rate and creeping up on 1,700 feet. So there we have an altitude capture. And notice when it sequenced to the altitude hold mode, the VS button turned black, meaning it's no longer functioning. And look at the annunciation here in the top bar, altitude hold at 1,700 feet. Now, for purposes of my simulator, I'm going to switch my knob control back to heading mode so that I can set my heading bug at the top of the DG. And now I'm going to change the lateral control mode to the track mode so that my autopilot will continue to fly that bug. You'll see no change in behavior because I was previously flying in a bank angle 0 roll hold mode. Now back to pitch control. We're currently level at 1,700 feet. The autopilot is holding that altitude. What do I want to do next? I would like to initiate a climb to, let's say, 2,500 feet. In the expert mode, you need to think of the climb, an altitude transition, as a 3-step process. And our 3 steps are: number 1, we have to designate a target altitude. Number 2, we have to choose a transition mode, and we have 2 of those, vertical speed mode or indicated airspeed mode. So that was step 2. And then the 3rd step is to designate a rate at which we want to climb with respect to the current, the selected transition mode. So I'm going to illustrate that three-step process. So step one, I said, was to designate a new target altitude. I'll switch my knob control back to altitude bug. Now I said I wanted to climb to 2,500 feet. So I rotate my altitude bug up to 2,500. And the altitude bug has changed, but notice we're not climbing yet. We're still holding altitude. That's because once the autopilot captures an altitude, the hold altitude is enunciated only in the status bar, and the autopilot ignores any changes in the altitude bug value at the top of the altimeter. That's why step one is to designate an intended altitude, but it doesn't start climbing to that altitude until we take step two, designating a transition mode. Now the reason it behaves like this, unlike the simplified autopilot mode in which the autopilot immediately starts climbing to a new bug, in IFR flying, oftentimes we'll know in advance what our next target altitude is, but we're not permitted to climb until the ATC gives us the release for the climb. So I already know I'm headed for 2,500 feet. I'm waiting for clearance to begin my climb. That's why the autopilot allows me to set a target altitude, but it doesn't depart my current hold altitude until I command it. So step one, target altitude. Step two, I have to choose a transition mode, either vertical speed or indicated airspeed. And on most aircraft, we tend to climb based on vertical speed. However, if you're flying a very high performance aircraft, you might choose indicated airspeed. Or if you're flying a low performance aircraft on a very hot day, high density altitude, you may choose an indicated airspeed value to achieve constant cooling of the engine, and you'll accept whatever vertical speed results. For my demonstration today, I'm going to choose the vertical speed mode, so I'll touch the VS button. Notice the button turned green, meaning that mode is engaged, but if we look at the status bar at the top, it says indeed we're engaged in the vertical speed mode, but the rate is 0. The rate in the enunciation bar and the rate on my vertical speed bug. Why is that? Well, the autopilot defaults to a 0 rate so that you can determine the exact rate you want to proceed at. So again, it's engaged in the vertical speed mode. It currently has a rate of 0, so it's not climbing or descending. It has armed the altitude hold mode, meaning it is prepared to capture an altitude when we arrive there. But again, we're still at 1,700 feet. The step three, I said, was to designate it a vertical speed rate. So now I will use my knob once again, set it to the vertical speed control. Now I can start dialing in a positive rate, meaning a climb rate. And I'm going to select a rate of climb of 400 feet per minute. You can see that's my vertical speed bug value. In the status bar, it's now enunciating vertical speed mode at a rate of 400 feet per minute. And it's raising the nose. Hopefully it'll get there. Flight Simulator is responding a little bit slowly. So I was very careful to say I needed to dial in a positive vertical speed. If I had turned the knob the wrong way and dialed in negative 400 feet per minute, the autopilot would respect that, and it would start down negative 400 feet per minute. It would still be in the armed mode for altitude hold, but it would never intercept that altitude which lies above us because I've told it to descend by virtue of a negative vertical speed rate. So you have to be careful to set the appropriate vertical speed, positive for a climb, negative for a descent. So we're proceeding on the climb. We're currently climbing through 2,000, almost 100 feet. And in another 300 feet or so, we'll see it sequence once again to altitude hold mode as it captures the target altitude bug value of 2,500 feet. And we'll just sit back and watch it. I will mention, since you're seeing it on screen, periodically I'm getting an enunciation that says trim nose down. The autopilot does recognize when it's having to hold constant control pressure, just like the pilot does. and we will enunciate to you the need to roll in some pitch trim. If you have roll trim installed in your aircraft, we'll also enunciate the need for roll trim. So here we are, we're sneaking up on 2,400 feet. In just a moment, you'll see the autopilot sequence to the altitude hold mode. Okay, it's sequenced, the altitude hold has turned green. We're still climbing through 2,400 feet, but it will start to moderate the vertical speed rate so that it can settle in and capture an altitude of 2,500 feet. And there we are, we're arriving at 2,500, and the nose is coming down, and the autopilot is leveling off. Here's a great chance for me to point out, notice that the autopilot leveled the nose at 2,500 feet, and it actually dipped slightly below. It actually went momentarily to a negative vertical speed rate. That's an artifact of how I have the autopilot tuned to fly with the simulator here. In your aircraft, there's a very explicit autopilot tuning guide that will help you adjust the autopilot control parameters so that it won't overshoot or undershoot your altitude on capture. That's a whole nother video, so I'll skip that for now, but I wanted you to recognize that that's what you're seeing if it has to oscillate a little bit in capturing altitude. It means that your autopilot needs more tuning in the pitch axis for perfect control. Okay. Now, I'm going to show you another method of commanding a climb. Again, I'm going to refresh. An altitude transition, climb or descent, is a three-step process. Step 1 was to designate a target altitude with the altitude bug. Step 2 was to select a transition mode, vertical speed or indicated airspeed. Step 3, designate a rate. So I'm going to do the same altitude climb, but I'm going to use the indicated airspeed rate this time. So step 1, designate a new target altitude. I'll adjust my knob to control altitude and dial in. We'll only go to 2,800 feet to shorten the climb. Step 1, target altitude. Step 2, the transition mode, I'm going to touch indicated airspeed. That mode is armed. I look up at the top. Indicated airspeed is, in fact, correction, that mode is engaged, a green bar. The mode is engaged here. It says my target indicated airspeed is 116 knots, which is the same as I am currently achieving. Just as in the vertical speed mode defaults to a vertical speed of 0, the indicated airspeed mode will default to your current airspeed, meaning the airplane will neither climb nor descend. It'll continue on at its current airspeed. So that was step 2. I designated the mode. Step 3, designate a target airspeed. In this case, I reset my knob function to the IAS bug control. And now I need to dial in a target airspeed. In this case, I need to select an airspeed less than my current airspeed in order to command a climb. If I dial in an airspeed higher than current value, the autopilot will lower the nose to achieve a higher airspeed, and that's opposite of what we want to do to achieve a climb. So again, indicated airspeed, I'm looking for a lower value than 116 knots. Let's tell the autopilot to climb at 110 knots. We'll see what that gets us. So 110 is my target airspeed. The autopilot is attempting to stabilize on a climb at 110 knots. Now you can see it overshot that pitch attitude a little bit, not unlike a new pilot, but eventually it will stabilize pretty close to 110 knots. And we've already commenced the climb. We're sneaking up on 2,700 feet. You'll see that the altitude hold mode is armed here, and it's going to transition or sequence in just a moment as we pass through 2,700 feet. I hope it will sequence. It's late. It's sequenced later than in my earlier example because my target airspeed of 110 knots resulted in a slower climb rate of only about 150 feet per minute. So it waited until it was closer to the target altitude before it sequenced to the altitude hold mode. But it has in fact sequenced. That mode is now engaged. The enunciation area at the top says altitude mode, target 2,800 feet, and you can see we're leveling off there. So you can see that regardless of the transition mode, vertical speed or indicated airspeed, the process was still 3 steps. Target altitude, select the transition mode, dial in a target rate for that mode. Now there's one way to shortcut that 3-step process, and that refers to these autopilot controls on the extreme right. They're in a group inside a box labeled nose, and it says nose up, nose down. I want to caution that some pilots misinterpret that as trim controls. The autopilot does not directly trim the aircraft, and these are not trim controls. Those are rate controls, and they will affect the autopilot performance regardless of whether it's selected into the vertical speed mode or the indicated airspeed mode. Whichever mode I have selected, pressing the up and down buttons will increment the respective rate. For vertical speed, it will increment VSI target rate in 100 foot per minute increments. If I were in the indicated airspeed mode, nose up and nose down, each press of the button will increment my target indicated airspeed bug value by 1 knot. So I said using those controls we could shortcut the 3-step process, and I'm going to do that now. Let's say I'm holding altitude at 2,800 and ATC says, calls me up and says, you're cleared to climb to 3,500, expedite your climb. They want me out of that altitude because someone else wants to be where I'm at. Instead of going through this 3-step process to dial my target first, I can shortcut by simply pressing the nose up button once. And watch what happens when I do that. I press nose up, the autopilot selects for me the vertical speed mode, but look here in the enunciation area, vertical speed 500 feet per minute. It chose a default climb rate for me. Unlike when I use the 3-step process, target altitude, then vertical speed, if I select the vertical speed button, it defaults to a rate of 0. When I use the nose up button, the autopilot says, you want a shortcut. I'm going to assume you mean the vertical speed mode, and I'm going to put in a default value for you. The value it uses as a default is defined by you in setting up the autopilot. In autopilot setup, you have a default climb rate and a default descent rate. And the autopilot selects those values when you initiate a transition up or down with either the nose up button or nose down button. So now I've commanded the autopilot into a vertical speed mode at 500 feet per minute. It's already climbing through 3,200 feet. I better remember to go back and designate my target intercept altitude of 3,500. And again, we'll watch it level off there. I'm getting a rate of 500 feet per minute. It's already sequenced to altitude hold mode, and it's going to start leveling off for 3,500. The danger of using this shortcut is something I've seen often in training IFR pilots, and that is the autopilot initiates the climb. It was armed in the altitude hold mode, but if I never changed the altitude bug value, the autopilot will continue to climb without a target. Now in IFR flying, eventually the ATC controller is going to call you up and give you a gentle reminder of your assigned altitude. So that is how you make altitude transitions. The same process holds for a descent. And let's do a shortcut descent method. I'm going to simply touch the down button. Down, the autopilot engages in the vertical speed mode. The altitude hold mode is armed. We're now descending at a vertical speed of minus 500 feet per minute. The autopilot has pitched us nose down, and what do I have to do? I have to set a target altitude for it to intercept. I don't want to intercept the ground. So I come back to my altitude bug, and I'm going to ask it to level off at 3,000 feet. And it'll do that fairly quickly. So that's a quick summary of you saw me engage the autopilot using the AP button. It will engage in the roll hold mode and vertical speed mode at the vertical speed you're achieving when you press the button. The next step typically is to set an altitude target so the autopilot will level off. You often will change the roll mode to either a bug mode heading or track bug, or maybe an HSI mode, a nav mode to follow the HSI needle. I've covered lateral navigation with the autopilot in an earlier video. The last item you might want to know about in the pitch axis is using the VNAV function. And you can see there's a button here, but it's grayed out. It's not currently selectable, nor is the nav mode. Both of those modes are dependent on the SkyView system having a valid navigation source for those modes to function. In my case, I don't have an HSI source selected, so I don't have any course to navigate. And similarly, I don't have a vertical guidance source, and so the VNAV mode is not available. I'll cover VNAV in a future video, possibly a couple videos. We recently added a vertical navigation feature associated with VFR GPS guidance, and it's related to our vertical speed required feature in SkyView. And then for you IFR pilots, of course, if you have an IFR navigator capable of providing vertical guidance, either a glide slope from an ILS or a glide path from a precision GPS approach, I'll show you how to use the vertical navigation mode to intercept the glide slope or glide path and have the autopilot fly that approach. So again, tune back for a future video in that series. Hopefully I can keep doing those in the simulator and you won't have to wait for the weather to clear here in the Seattle area. But for now, thanks for joining me, and come back again.
For more information on planning or capabilities of the SkyView system, please see our website at dynonavionics.com, where you can find links to our system installation guides, pilot user guides, and other valuable information like our user forum. Thank you for watching the Dynon channel.